Hi, welcome back to Mr. Slover's Math. Today we're going to talk about functions. You're going to determine if a relation is a function. So this is just a warm-up of what we did yesterday, just graphing on a graph. So a function is a relation that has exactly one output for every input. Function must pass the vertical line test. So this is used if the relation is graphed, or typically that's when it's used. So on the left side, we have the function. On the right side, we have non-functions. So over here, these are all functions. I have one input and one output. 16 goes to 4. 4 goes to 2. 9 goes to 3. This over here passes the vertical line test. So if I take my finger or my pencil and I go straight up and down, it only intersects the line once. Hence, it passes the vertical line test. So over here, these are non-functions. So -3 goes to 6, -2 goes to -1, -1 goes to 0, 0 goes to 3. But then right here, I circled it, 1. If that's my input, it can only go to one output, but it doesn't. It goes to two different outputs. It goes to 0 and it goes to 15. So that means it's not a function because there's not one output for every input. On a graph over here, this fails the vertical line test. So if I take a pencil or I take my finger, right here I drew in a red dotted line, it intersects that what's graphed in two different spots. So it fails the vertical line test. It can only pass through a vertical line once. Function notation. Instead of saying y equals 3x minus 8, we could say or write f of x equals 3x minus 8. So this f of x is just a different way to say the letter y. It's function notation. This is my function because your functions can change. You could have more than one function in a problem. So down here, this is just a quick tidbit on the three different parts. F is the name of the function. This tells you that x is the input. So anytime I see an x, that's going to be my input. And this tells you what the function does. So in this case, this function multiplies the input by 2. So if this is multiplying my input by 2, that means that this right here actually represents my output. So example 1 is asking you to determine if the following relation is a function or not. Defend your answer. So notice that they all have the same box because it's asking the same question. Does it pass the vertical line test? Nope. Yes. Is there one input for every output? No, because a sub 1 is going to two different outputs. Is there one input and one output? Yes. So down here, so now we're getting into the function notation and how we can apply it. It says for f of x, when it's f of x equals 2x plus 8, it's asking you to find the value, and it says f of 2. So right here, I wrote what you're supposed to do. Where you see an x, you're going to plug in 2. So I see an x, I plug in 2. 2 times 2 plus 8, and then I follow those order of operations. Same thing over here. Now it's telling me x is -1. So I plug in -1 where I see an x and I perform my order of operations. Same thing here. Example 3 is a bit different because there are two functions. One of them says f of x equals -4x plus 7, and the other one says g of x equals 2x plus 3. So notice that this one says f of -3. That means I focus only on the f function. So f of -3, where I see an x, I'm going to plug in -3. So -4 times -3, and then I add 7. And then over here it says g of 2. So I look at my g function, and anywhere I see an x, I plug in 2. 2 times 2, then add 3. And then lastly, this last part is you looking at a graph and interpreting what it means. It says evaluate the function from a table or from a graph. So this is more like what you're going to see outside of the math classroom. You're going to see a chart with some different information, or you're going to see a graph and you're expected to understand what that graph means at certain locations. So first off, you got to make sure you read everything that's already on there. So this is telling you that this is talking about the snail speed as a function of time. Over here it talks about the speed per minute, and over here, the speed, the centimeters that it travels. And over here it's talking about the time. Down here, it's talking about a charge for delivery. So however many miles you are depends on how much it's going to cost. So this is saying evaluate and then meaning. So this is the function notation, and the meaning is you describing what it means. So s of 7 equals, and it was blank. So s of 7, well, s is your seconds. So at 7 seconds, it's asking how far the snail was. So I go over here, 7 seconds. I go all the way up until I see the graph, and in this case it's at 10. So s of 7 equals 10. Now if you think about it, it's saying s of 7. Remember, this is really my x value, and this is your x-axis. If it was a graph, right, a coordinate plane, that would be your x-axis. So on the x-axis at 7, what's my y value? In this case, it's 10. So it's saying after 7 seconds, the snail was traveling at 10 centimeters per minute. So this one is similar, but this one I'm having you work backwards. It says after 12 seconds, the snail was traveling at a speed of 8 centimeters per minute. So I'm describing what you are supposed to write. After 12 seconds, the snail was traveling at a speed of 8 centimeters per second. Okay, so after 12 seconds, we were going at 8 centimeters per minute. Okay. And then likewise for the graph down here, right? Same concept. If you have